MacMaths, let's do some maths today. Okay, so this is AS Mechanics, Chapter 10, Connected Particles. We've just done Part A, and now I'm doing Part B, which is why I've ticked in red for your Part B. We're going to look at simple cases, blocks connected over a pulley. Favourite of EdXL mechanics. Okay, and I've still obviously got the colourful spiral for you there to have a look at. You can zoom in on that if you want, put it on pause or zoom in and have a look at that. Okay, so if I move that out of the way, now we started with Part A. In my example, I started with two blocks that were connected by a string, a tight string, and pulled along, and they were 4 and 2 kilograms. So now what I'm going to do, I'm only going to do one example with you, and then I'm going to give you two questions the same to do yourself and put them on pause and then have a go at them, and I'll go through those two questions. The reason I'm only going to do one example with you is because simple pulleys are always done the same way. So you do every pulley question, you will do it at the start, whatever the question is, whether it's one of the more difficult ones or simple ones or whatever, you will always do it this way. So here it is. It might describe it, it might draw the diagram for you. If it draws the diagram, easier, okay, but it might describe it and you have to draw it yourself. So always draw the diagram, 4 kilograms and 2 kilograms. Here they are, threaded over a pulley. It's tight now, it's held at rest, but you can see that this side is heavier, so when we let go, this is going to start hurtling down, and that is going to start hurtling up at the same acceleration as it. So down, accelerating down, and accelerating up as the string stays tight and they run over the pulley. Common sense. So let's put the forces on. Now, the tension in the string. The tension in the string, it acts away from the 2 kilograms. It also acts away from the 4 kilograms. So it's the tension that's pulling the 2 kilograms up, but it's actually the tension that is slowing the fall of the 4 kilograms coming down. So let's put our weights on, okay? So this is mg. So on this side, it's going to be 4 times 9.8 is the force acting down. And on this side, the mg, the mass times gravity, the weight of this is 2 times 9.8, okay, newtons. So these are the two weights, the forces acting on either side of this pulley system. Now on this side, it's accelerating up, isn't it, that way, and on this side it's accelerating down because that's heavier, so it's going down, it's accelerating that way. Now in the first lesson I said that you try to consider them as the whole thing, and we're going to go back to that when we look at caravans and cars. But in this case, in pulleys, you can't do that. You cannot look at them as a whole thing because they're moving in different directions. One's moving up, the other one's moving down. So what you always do with all pulleys is separate them out. Okay, so on every pulley question, separate out your pulley and just consider them separately. It allows us conveniently now to choose a different direction for the positive. So we're going to keep this positive and say that up is positive. On this side, we're going to say down is positive because we're going to keep them separately and do the math separately. Okay. So always with every pulley question, put your two forces on. Your forces will always be just the 2 weights and the 2 tensions. Draw your acceleration going up, the one that's the lighter, and the acceleration going down, the one that's the heavier. These two values are going to be the same. The tension in the string stays the same. Okay. So once we've done that, we've just got to do the maths. So please, do them separately. So I'm going to do them separately now. Now in this question, you're going to always get asked to find the only 2 things that you don't know is the tension and the acceleration. Okay. So let's do that. So we're going to do A and B. So this is what you do. Every single question, please do them this way. They might call it P and Q, but do a separate equation, and do them side by side. Okay, so let's have a look at the A side. So let's apply F equals MA to this. So we're not looking at that now at all. What's happening? It's moving down. So this mg is the driving force. Okay, the net force then that's driving it down is not this, it's not the full weight, it's not in free fall, it wants to fall with this weight pulling it, but actually it's been held back a bit by the tension, isn't it? So the net force is the mg minus the tension on this. So it's the mg is driving it down and the tension is holding it back. That's the net force, okay? Times the mass times acceleration. Well, the mass on this side is 4 and the acceleration is a. We don't know that. Now we know what mg is. It's 4 times 9.8. So 4 times 9.8 is equal to 39.2. So we've got an equation now, 39.2 minus t is equal to 4a. So one equation, two unknowns. We don't know the tension, we don't know the acceleration, as far as we can get with that. Let's look at B, this side now, separately. Okay, this is a system that is moving up. You know, it's been pulled up by the tension. So if we apply F equals ma, it's not being pulled up by the full force of the tension because there's weight that's holding it back. So this is a retarding force. It's slowing it down a little bit. Okay, so the net force is now the tension, that's the driving force pulling it up, minus the 2 times 9.8, the mg, the weight of this particular block. Okay, and it doesn't know what's going on the other side, we're just looking at this. And the mass is 2 times the acceleration. So we've got this equation. We know what mg is for this side. It's 2 times 9.8, which is 19.6, is equal to 2a. Now we've got two equations and two unknowns, and we can solve those simultaneously. Now it's entirely up to you. Be careful with minuses. You can just write that the other way around and line them up by the elimination method if you want. I sometimes do it that way. It's entirely up to you, but you're just substituting one into the other. I'm going to do this one by substitution. I'm going to take that t there and I'm going to stick it into that there. Okay, that's what I'm going to do. So I'm going to rearrange it first of all. This t on this side is equal to 2a plus 19.6, isn't it? Adding 19.6 to both sides. And then I'm going to put it into there. So now I've got 39.2 minus all of that. So I've got 2a plus 19.6 is equal to 4a. Okay, so I've just put that in to there. Now you've got to be careful. The danger here, isn't it? The inexperienced mathematician would just do 39.2 minus 2a plus 19.6, but it's minus all of that. So it's 39.2 minus 2a minus the 19.6, getting rid of the brackets, minus those two things, is equal to 4a. Adding 2a to both sides gives me 6a. Okay, and then that leaves me on this side with the 39.2 minus the 19.6, and that gives me 19, oh 19 points, of course it does, idiot, 19.6, and divide that by 6, and that gives me 3.2. You can see now why it would be better to leave it in terms of g, but I'm going to go 3.27 meters per second to the minus 2. That's the acceleration. Okay, so we've got the acceleration now, so that means it's accelerating up at 3.27 there, and it's accelerating down at 3.27. And the tension, you can stick it into either of those, doesn't matter. To get the tension's the same on both sides. That's the easiest one. So the tension is equal to 2a, 2 times the acceleration plus 19.6. And I've got the acceleration more accurately on my calculator. So I'm going to times that by 2 lots of the acceleration plus the 19.6. So times by 2 plus 19.6, and that gives me 26.1 newtons. Okay, that is how we do all of the pulley questions. Draw a line down the middle of your pulley, separate the two sides out, call them A and B or P and Q as you usually get, whatever it is. and set up those two equations. It's always like that, every single one, trust me, is like that. Okay, so what you're going to do now that we've got the acceleration and the tension in that one, what you're going to do is you're going to have a go at a couple of questions. So I'm going to get those out for you now. So I've written those. There we go. There they are. So 2 blocks, masses M and 3M. We don't know what M is. Respectively hanging over a pulley, connected by a light and extendable string. That's what it would look like on the exam. The system is released from rest. Find the acceleration and the tension in the string. Obviously things are going to be in terms of M. Okay, and I've changed this one, just a different emphasis on it. Same maths, 2 blocks P and Q, hanging over a pulley, connected by a string. Q is 6 kilograms. Now I've given the acceleration, but I've not told you what P is, so you've actually got to rearrange the equations and find out the mass of P. Okay, so have a go at those questions, put it on pause, have a go at them, and I'm going to go through those in a minute. Okay, so pausing now and you're having a go at those. Okay, if you're back with me, right, let's have a go and do these questions. You'll see me do these exactly the same way as I did my example, because like I said, pulleys are done all the same way. So here, the first one, 2 blocks M, capital M it is, and 3M. There it is. Okay, respectively hang over light, and you've got to find the acceleration and the tension. Okay, so let's put our things on. Tension acting away, mg, but mg here is 3m, so it's 3m, 3 capital M, whatever weight 3 lots of m is, 3mg acting down, and capital mg acting down on that one, so those are the forces. This is the heavier, so it's going to be accelerating down that way, and that's going to be accelerating up. Split it into 2, like I said. We're going to have the m side and the 3m side. Okay, on the m side we're going to apply F equals ma. Look at the m side, it's accelerating up, so the tension is the driving force. So I'm going to go T minus mg is equal to this mass, which is ma. So T minus mg is equal to ma. And because I don't know what m is, I can only leave it as a capital M. On this side, if I go F equals ma, then I can see that it's travelling down, so 3mg is the driving force being held back by the tension. So the net force is 3mg minus T is equal to the mass. Well, the mass of this is 3m times the acceleration. Okay, so we've got 3ma. Okay, we're going to do it the same as we did it before. And I'm going to just rearrange this one, and I'll do it in a different colour. Actually, I don't know what my orange is like. Ooh, that's quite nice. It's not dark enough to stand out. Let's go blue. No, let's go purple, which is the thinnest. Oh yes, lovely. Okay, if I rearrange this one, I can say that T is equal to ma plus mg, and then I get that T and I stick it into there. So then I can go 3mg minus all of T, which is, I know, is ma plus mg, is equal to 3ma. Okay, so let's work this out now. So we've got 3mg minus all of that, so minus the ma minus the mg is equal to 3ma. Now those m's are all the same, aren't they? And I can simplify it here. I can just divide through by m straight away, but I'm just going to simplify it and go 3mg minus mg is 2mg, and I'm going to add ma to both sides, so I get 4ma on that side. I'm going to divide through by m now, so I get 2g is equal to 4a, and I'm going to divide by 4 both sides, and I get the acceleration is 2g over 4, which is a half g. And we know that g is 9.8, so 4.9 meters per second squared. That is the acceleration. So in any system where this block is 3 times the weight of that block, 3 times the mass of that block, that will be your acceleration. The acceleration will be 4.9 meters per second squared. Now that will always be the acceleration, but the tension depends on what m is. So the tension we can only find in terms of m. So the tension is equal to, using this equation here, just making sure that fits on my screen. It does, doesn't it? Okay, the tension is equal to ma, and we've got m times the acceleration, so times 4.9 plus m times 9.8. So the tension, of course, is 4.9m plus 9.8m. So the tension is 4.9 plus 9.8 is, what's that, 14.7 m, and it's newtons, isn't it? Okay, so 14.7 times whatever the mass is, newtons. That would be the force, the tension in the string. Okay, so that is number 1. And you sometimes get those questions where they just don't give you the actual mass of it, they just give you it in terms of a letter. Okay. Alright, so I hope you got 4.9 meters per second squared, and I hope you weren't fooled by the 3m and the m. It looks complicated, but actually it's quite simple, isn't it? Okay, it's just all those m's. And there was another one, wasn't there, that I gave you. This time I just did it a different way around. So I gave it to you. Let's get rid of that now, we don't need that one. 2 blocks P and Q are hanging over a pulley connected by a string. So I don't know why I squashed that other one up there. P and Q. So let's go P and Q. Mind your P's and Q's. Hanging over a string, connected by a string, blah, blah, blah. Q has a mass of 6, blah, blah, blah. When the system is released, Q starts to accelerate down. So it told you that, and the acceleration is 2 meters per second squared. So Q is accelerating down, and P we don't know. So in fact, get lost. Let's put the P inside there now. We don't know what that is. Okay. We've got mg acting down, and we know that that is, of course, 6 times 9.8. And we've got the mass of P. We don't know what the mass of P is, so I'm leaving m. And mg acting down, and of course, let's get the tensions in. We know that they exist, so 2 tensions there. All right, so there's our situation, and we've got to find the tension in the string and the mass of P. So what do? We do what we always do, or what I've told you to do, is to separate it out. So I'm going to have a P side and a Q side. There it is, P and Q. And let's have a look at the P side. Now, we're told that this is going down, so we know that this is accelerating up, this one, doesn't it? So applying F equals ma, and the force acting up here, the driving force of this one is the tension, isn't it? And it's going to be minus mg, okay, is equal to the mass, which we don't know, times the acceleration, which we know is 2. So T minus mg is equal to 2m. All right, we've got that. This side, we're going to be able to find out a little bit more. We're going to be able to find out that tension when we do the Q side. So the Q side is F equals ma, and the Q side was more helpful to, I should have done this one first really. The net force, this is pulling it down, so mg is pulling it down. And you've got to be careful, the mg's on the 2 sides are 2 different things because they're the weights, you know, not looking at the other one. So this is mg acting down minus the tension, because it's going that way, and this is the driving force. Take away a little bit of that, whatever the tension is that's trying to hold it back, is equal to the mass. We're only considering this side, and the mass is 6, and we know that the acceleration is 2. So we've got that. Okay, we know what mg is, don't we? the mass is 6, so 6 times 9.8. We've got that force. The weight of it would be on 6 times 9.8. The weight of that would be 58.8. So we've got 58.8 minus t is equal to 12. And taking the t over there and the 12 over there, we get 58.8 minus 12. And we've got the tension, haven't we? Which is 46.8 newtons. Okay, so we've got the tension in the string now, or a tension in the rope. We're going to put that into this one, so we can go take that and put it into there, and now we can go 46.8 minus, now mg, m is the mass of p. We know that gravity is 9.8, so 9.8 m times the mass is equal to 2 times the mass, the acceleration times the mass. So therefore we get 46.8 is equal to add 9.8 to both, 9.8 m to both sides, and that's 10.8, 11.8 m, and then we divide both sides by 11.8 to find the mass. So let's do that. So 46.8 divided by 11.8, that gives me 3.966 recurring. Blimey. So 3.97 kilograms. Now it's not the weight, it's not newtons, it's the mass. So it's almost a 4 kilogram block, isn't it? It would be to one significant figure. Okay, so those are those two questions. I hope you did those two okay, and I hope you increase your understanding of pulley systems. Okay, the next part as well is going to also be about pulley systems, but we're going to start applying the equations of motion. All right, so there you go, over and out.